こんにちは、タックです。今日のスピーキング練習を始めます。Flightless birds. Certain birds whose ancient relatives once flew have lost the power of flight and have adapted to other modes of living. The largest such group of birds, called rattlets, includes ostrich, rhea, emu, cassowary, and kiwi. Two extinct rattlets are the elephant birds and the moa. Unrelated to the rattlets are the penguin, whose flipper-like wings help it to swim, and the extinct dodo. According to theory, birds are descended from pseudoscians, reptiles that began to live in trees about 225 million years ago. With the passage of the time, the scales on the bodies of these reptiles are believed to have evolved to feathers. This was accompanied by the gradual modification of the forelimbs into membranous wings, making it possible for these animals to leap from trees and glide to the ground. From these reptiles, Archaeopteryx' ancient wing evolved. According to theory, this warm-blooded animal could use its wings to rise up and move through the air. Archaeopteryx, the first true birds, probably appeared some 136 million years ago. If all birds are descended from Archaeopteryx, where then do flightless birds come from? This question has puzzled scientists for a long time. Some suggest that modern birds have two common ancestors instead of one. The first line of descent, representing the majority, attained flight long ago. The other line, flightless birds, is at an early stage of evolution. Most experts reject this view today. They say that flightless birds had flying ancestors but lost the use of their wings because they did not need them to survive. Symbiosis. Close living arrangements between two different species is called symbiosis. The word comes from the Greek word meaning state of living together. Usually the two organisms are in close physical contact, with one living on or in the other. In some cases, however, the relationship is less intimate. Symbiosis is classified into mutualism, once called symbiosis, commensalism, and parasitism. These relationships range from mutually beneficial to harmful, or even fatal, for one of the species. In mutualism, both partners benefit from the relationship. One of the best-known mutual relationships is one between nitrogen-fixing rhizobium bacteria and several leguminous plants such as beans, peas, peanuts, and alfalfa. Human beings, animals, and most plants need nitrogen to survive, but cannot metabolize it from the air. Rhizobium bacteria, which live in the soil, enter the roots of legumes and produce nodules or enlargements in which they absorb nitrogen from the air and convert it into ammonia. This compound is then converted into some organic form, such as amino acids, which is shared by the bacteria and the host plant. By eating such leguminous plants, other organisms obtain a rich source of nitrogen-bearing compounds. The bacteria in turn benefit from the relationship by absorbing from the host plant nutrients that they cannot manufacture themselves. Lichens, which consist of fungi and algae, are another well-known example of mutualism. Algae receive shelter and the moist environment by dwelling within the fungi. In turn, the algae provide fungi with food through photosynthesis. Introduction. Biochemistry is a science concerned with chemical substances and processes that occur in plants, animals, and microorganisms. Specifically, it involves the quantitative determination and structural analysis of the organic compounds that comprise the basic constituents of cells, proteins, carbohydrates, and lipids, and of those that play a key role in chemical reactions vital to life. Nucleic acids, vitamins, and hormones biochemistry entails the study of all the complex interrelated chemical changes that occur within the cell, e.g., those relating to protein synthesis, the conversion of food to energy, and the transmission of hereditary characteristics, both the cell degradation of substances that release energy and build up of complex molecules that store energy or act as substrate or catalyst for biological chemical reactions, are studied in detail by biochemists. Biochemists also study the regulatory mechanisms within the body that govern these and other processes. Biochemistry lies in the border area between the biological and physiological science. Accordingly, it makes use of many of the techniques common to psychology and those integral to analytical, organic, and physical chemistry. The field of biochemistry has become so large that many subspecialties are recognized, as, for example, clinical chemistry and nutrition. Molecular biology is a study of large molecules, for example, proteins, nucleic acids, and carbohydrates, that are essential to life process is a field closely allied to biochemistry. Taken as a whole, modern biochemistry has outgrown its earlier status of an applied science and has acquired a place among the pure or the sciences. Digital computer. A digital computer typically consists of a control unit, an arithmetic logic unit, a memory unit, and input-output units. The arithmetic logic unit ALU performs simple addition, subtraction, multiplication, division, and logic operations, such as OR and AND. The main computer memory, usually high-speed random access memory, RAM, stores instructions and data. The control unit fetches data and interactions from memory and affects the operations of the ALU. The control unit and ALU usually are referred to as a processor or central processing unit CPU. The operational speed of the CPU primarily determines the speed of the computer as a whole. The basic operation of the CPU is analogous to a computation carried out by a person using an arithmetic calculator. The control unit corresponds to the human brain and the memory to a notebook that stores the program initial data and intermediate and final computational results. In the case of an electronic computer, the CPU and flash memories are realized with transistor circuit. I/O units or devices are commonly referred to as computer peripherals and consist of input units, such as keyboards and optical scanners for feeding instruction and data into the computer, and output units, such as printers and monitors, for displaying results. In addition to RAM, a computer usually contains some slower, but larger and permanent secondary memory storage. Almost all computers contain a magnetic storage device, known as a hard disk, as well as a disk drive to read from or write to removable magnetic medium, known as floppy disks. Four seasons. Latitudinal variations in the input of solar energy are due to two factors. First, the Earth is a sphere, and the angle at which the sun's rays hit its surface varies from 19 degrees or vertical near the equator to 0 degrees or horizontal near the poles. Less energy is received at the poles because the same amount of radiation is spread out over a much larger area at high latitudes, and because at high latitudes the sun's rays must travel through a much greater thickness of atmosphere, where more absorption and reflection occur. The second factor affecting latitudinal variations in heating is the duration of daylight. Because the polar axis of the Earth is tilted at an angle of 23.5 degrees with respect to the ecliptic, we have a progression of seasons, where the angle of the sun's rays striking any given point varies over the year. In the northern hemisphere winter, no sunlight strikes the area around the North Pole during a full day's rotation of the Earth, because it is in the Earth's shadow. Thus, little or no solar heating occurs in this area at this time. Conversely, at the South Pole, there is continual daylight, but at a very low sun angle during the northern hemisphere winter. As the seasons shift, the South Polar region eventually becomes plunged into 24-hour darkness. Just as the North Pole had been earlier, low-latitude regions near the equator, by contrast, undergo little seasonal change in the duration of daylight, whereas intermediate latitudes are subject to changes intermediate between those of the poles and the equator. Thus, because of seasonality, more annual radiation is received per unit area at lower as compared to higher latitudes. 終わり。